The diagram shows the curve with this equation. The curve crosses the x-axis at A and the y-axis at B. Find an expression for dx dy in terms of y. Find the gradient of the curve at each of the points A and B. Give me each answer correct at 2 decimal places. Okay, here's the question then. We've got this. It's a product, and the second term is itself a function of a function in terms of y, isn't it? So part 1 then. So let's differentiate with respect to y. So use the product rule. U y plus 4, u dv dx. So this differentiate with respect to y, isn't it? Because we're doing differentiation with respect to y. Log of something goes to 1 over something, multiplied by the something differentiated. And we're differentiating with respect to y, so it's the same process. So this just differentiates to 2, doesn't it? So that's v u dv dx plus v times du dx, and this differentiates with du dy will be 1, won't it? So what have we got then? We've got 2y plus 8 over 2y plus 3 plus ln 2y plus 3. And that's dx dy. So dy dx will be 1 over this. Find the gradient of the curve at A and B. So at A, y equals 0. So at A, y equals 0. So dx dy then, put 0 in for A. 0 plus, it's put 0 in 8 over 3 plus ln of 2 ln 3. So that tells us then dy dx is equal to, it's 1 over this, isn't it? So let's do that. 1 divided by bracket 8 divided by 3 plus natural logarithm of 3. Close the log bracket, close the bracket. 1 divided by 8 divided by 3 plus log 3 equals 0.265584. So that's the gradient there. And that equals, what do we need to find out, to 2dp? So that's equal to 0.27 to 2 decimal places. Okay, so now at B, x is 0, isn't it? So when x equals 0, what does y equal? Okay. At x is 0. Okay. So y would equal minus 4, wouldn't it? Here. And y equals, well, this clearly 2y plus 3 will be non-zero up to about here, won't it? Or here, of course. So when y is minus 4, x is 0. Let's have a look at that, because there's a problem there, isn't there? Because when y is minus 4, this is not defined, because it's negative. So it must be when this is 0. So when does this equal 1? So 2y plus 3 equals 1. Right, so y would equal 1 minus 3 is minus 2 over the 2 equals minus 1. So this value here is minus 1. That's it, that's the value. So dx dy then is equal to, this will be 0, so it's simply 8 take 2 is 6 over 3 take 2 is 1 equals 6. So dy dx is equal to 1/6. And 2dp, 1 divided by 6 equals 0.17. That's to 2 decimal places. Okay, it had to be that, didn't it? That had to be the value, because be lower than that, this wouldn't be defined anyway. Because the lowest y value it can have is when this is 1. This is 1 when y is -1. We get the value 1 log 1 is 0. And that's it. No, this could equal tend toward 0 as well, couldn't it? But we know that it is 0, log 1 is 0, and that's when x will equal 0, so we know this value is -1. Yeah? Okay, good. So that's clear, hopefully.